Okay, now we're looking at non-linear simultaneous equations with two unknowns, which is exercise 211 from Maths in Focus and the new Mathematics Extension 1 course. Again, this is still, actually all of these three things are actually mathematics, not extension mathematics. So just to remind you, we looked at linear, in other words, just one answer for two unknowns. We looked at them last lesson. For example, you got a equals -1, b equals 4 for the first example, and then hopefully you followed through and did, I use a substitution method, but you could do the elimination method and got an answer for the second example. And you've worked on these exercise 210 now, just the odd ones. Now the difference between these, the ones we just did, and the ones we're doing now, is that you may get more than one answer. I say may because there's nothing definite about it. But you notice this is non-linear. So it means graphically, and I'm going to draw a graph up there right now. Graphically, one of these don't look like a straight line, a linear equation. So anyway, let's get stuck into it and then we'll analyse what it means. So we'll call them equation 1 and equation 2. Now, in terms of which method you're going to use, you can't really sub one into the other because this is x times y. And if you could times this by y to make xy here, but then you've got a y squared, which causes its own problems. So anyway, what do? You make x or y the subject of one of them and sub it into the other. In other words, use the substitution method. And it really doesn't matter which way you do it, because if you make x the subject of this, you get 6 over y, or if you make y the subject of this, you get 6 over x, or you make x the subject of this. Either way, you're going to end up with the same sort of results. I'm going to take this one, equation 2, and I'll make x the subject of it. So make x the subject, which means put it on its own, of course, of equation 2. So I'll get x equals 5 minus y, but moving the y over there. That's equation 3, which is really just equation 2. And then sub that's equation 3, into equation 1. So you can see where x is, 5 minus y, that's going to go in there where x is. So you get, instead of xy equals 6, you get 5 minus y times y equals 6. Now, this is why you had a lesson, or a day yesterday, as in Wednesday, solving quadratic equations, because that's what this is. It's a quadratic equation. You're going to get you're going to get 5y minus y squared equals 6 when you expand it. So you have to think to yourself, what are we going to do to solve this equation, this quadratic equation? So that's where you've got the whole three methods: factorising, completing the square, or the formula. So I'm going to see if this factorises. So if it factorises, that's the nicest way to do it. Now I want y squared to be positive, so I'm going to make this side 0, move everything over this side. Y squared minus 5y plus 6. Now we look to see whether, as a quadratic trinomial, you've got two things that multiply to give 6 and add to give -5. Because they add to give something negative and multiply to give something positive, they're both negative. And of course they're 3 and 2, -3 and -2. So we do get two answers. We get y equals 2 and y equals 3. So that's where this is different to the ones we did last lesson, because they're only ever had one value of x and one value of y. This one has two, and we'll show you what that means in a minute. So it just means you do them separately now. So sub into, which one are we going to sub it into? Of course, because you have x equals, sub it into equation 3, x equals. So sub it into equation 3. Anytime I draw a circle around it, it means equation. If I don't have a circle around it, it means a number. So I'm going to sub it into equation 3. Equation 3, I'll rewrite it here, is 5 minus y. So I'll stub that in here, y equals 2 into here, and you get x equals 5 minus 2, which is 3. So we have x equals 3, y equals 2 as one of the solutions. We'll check them in a minute. Over here, y equals 3, sub that into equation 3. You get x equals 5 minus 3, and of course you get 2, sort of the opposite. So x equals 2, y equals 3 is a different solution. They are the same numbers, but they are different solutions. And if you check it quickly, remember 3 and 2, and 2 and 3. If you check it quickly up here, you get 3 times 2 equals 6 and 2 times 3 equals 6. And over here, 3 plus 2 equals 5 and 2 plus 3 equals 5. So it works. Now, what does it mean graphically? I'm going to draw the graph back down here because it's actually very, I suppose it's incomplete to think about this without thinking about a graph. So we have two, I'm actually going to do it on another bit of paper. We have 2 graphs I want to draw. The 2 graphs I want to draw are, the first one, x, y equals 6. That's the first equation we had. And the second one is x plus y equals 5. Now, this is not a graphing section now, but it just helps you realize where this all fits together. X plus y equals 5 goes through 5 there, and has a dead straight line like this. That's that one. X plus y equals 5. xy equals 6 is actually a hyperbola. Now, if you might remember that, but hyperbolas actually look like this. Come down like this, bend and go like that. And there's another branch over here. There's 2 branches to it. So this is actually xy equals 6. Now, the only reason when I'm mentioning that now, and remember, do not panic, we're not doing this topic now. This whole big topic is called functions, which is what this has got to do with. But right now we're just practicing getting the solutions. So the question I have is, what does this mean in terms of this? And I reckon you're probably cluey enough to realize that means that this point of intersection is 3, 2, and this point of intersection is 2, 3, and suddenly it even looks right. So I think it's nice to remember that this is what's actually happening. All right, let's do the next one. Now, the next one is actually quite challenging. It is another one. There's only 2 examples we're doing, non-linear. X squared plus y squared equals 16, and 3x minus 4y minus 20 equals 0. It is, I'm going to give you a little bit of a tip here. It's on page 71 of the textbook if you're wondering why I take a couple of shortcuts. All right. Okay, so what are we going to do? We have to combine these together. So we have to choose how we're going to put these together. It is not nice. I can't make x the subject of this nicely or y the subject of this. In fact, I'll lose one of the answers if I do. You've got to make x or y the subject of the second one. So let's say make x, actually I'll do the same as the textbook for consistency. I make y the subject of that second one. So make y the subject of equation 2. So I've got to get that on its own. So what I'll do is I would add the 4y to the other side. 3x minus 20 equals 4y. Divide by 4, 3x minus 20 all over 4 equals y. And then that fairly horrible thing has to go in where y is here. So that's what actually happens. I'll call that equation 3, sub equation 3 into equation 1. And this is where it gets a bit horrible because you end up with x squared plus 3x minus 20 over 4. Is that all squared? Yeah, that's all squared. Equals 16. So to solve that, you need to expand this side, have a common denominator of 16, add it all together, and you get, so these are steps, which I really don't have time for and space for here. You end up getting 16x, actually I'll go to the simplest answer actually. You end up getting 25x squared minus 120x plus 144. And to solve that could be even in itself a fair bit of work. So just to remind you, so we've pretended we've expanded that, got a common denominator of 16, added it together, expanded it and added like terms, make it equal to 0, you get to this. Again, see page 71 if you want to follow that. All right, so this is actually, because 25x squared is a square number and 12 squared is a square number, it's a pretty big clue that this is a perfect square. And it actually is. If you multiply them together and double it, you do get minus 140, because I get minus 60, you double it, minus 120, minus 120. So it is equal to this. So that's sort of done it by factorising, or completing the square. It's really the same thing. Then square root both sides, and then you have to make the solve for x. So what this means is you're actually only going to get one answer, 12 over 5, which is, Nice. It's 2.4. It's about 2.4. What is 2.4 exactly? It's nice that we only got one answer because it means that the amount of work that we have is halved compared to before. So now you've got to sub that into equation 3 to get the value of x. No, to get the value of y. So you get 3 times 2.4 minus 20 over 4 to get what y is in one go. And I'm just trusting Margie from the textbook, the author, minus 3.2. So we've got an answer for x and y. Now you should sub them in to check that it works for this and works for this. We'll just take her word for it. I just want to finish off before you do these. These are the questions you need to do, but I want to finish off by looking at what that means graphically. So the first thing I want to say is, what is x squared plus y squared equals 16? What does that look like? Again, remember, this is not our topic now. We might remember that's a circle. X squared plus y squared equals 16 is a circle. Okay, now look at this. We're saying we're getting one answer here as a point of intersection between this circle, x squared plus y squared equals 16, and 3x minus 4y minus 20. 3x minus 4y minus 20 equals 0. So, where is 2.4 minus 3.2? 2.4 minus 3.2, it's going to be somewhere down here. What does it mean that we only got one answer? Because most of the time you'll get two. It means that this is actually a tangent. It actually just touches this. And you can just check this by one more little thing. You can put in into this equation, put in x equals 0 to get the y-intercept. So that means you get minus 4y equals 20, so y equals minus 5, and that looks like it would be about minus 5 if that was minus 2.4. So again, don't get confused. This is actually looking a little bit further ahead if you drew it graphically, what it looked like, because then that actually starts to make sense. All right, as I went through that one quite quickly. There's going to be some hard questions in here, but this is the lesson you need to do yourselves at any time. Exercise 2.11, the odd ones again. Good luck with that.